Across the Australian continent, engineers are trying to build one of the most ambitious railways in the country's history. A 1,600-kilometer freight line connecting Melbourne to Brisbane, a steel spine running through the center of Australia. Supporters once called it a Suez Canal on tracks. The promise was simple. Freight trains would cut straight across the continent instead of following the slow coastal route. The journey between Melbourne and Brisbane could drop to less than 24 hours. Longer trains, double-stacked containers, fewer trucks on highways. If it worked, inland rail could completely reshape how goods move across Australia. But mega projects are rarely simple. As planning turned into construction, costs exploded, deadlines slipped, and the project that once promised to transform the nation slowly became one of Australia's most controversial infrastructure gambles. To understand why, we first need to understand the problem inland rail was meant to solve. Australia is massive in size, but its population is small and spread unevenly. Most of the country's 26 million people live along the east coast: Melbourne, Sydney, Brisbane. These cities form a powerful economic triangle. Every day, goods move constantly between them. Food from farms, building materials, electronics, supermarket stock. For decades, trucks have done most of this work. Drive along the Hume Highway between Melbourne and Sydney, and you will see endless lines of heavy freight trucks. Some pull 2 long trailers. They travel day and night. But trucking has limits. Fuel costs are high. Highways wear down faster. Traffic congestion grows worse each year. And heavy vehicles produce more emissions per unit of freight. As Australia's population grows, freight demand grows with it. More people means more goods. So experts started asking a simple question: can rail do this better? The answer seemed clear. One freight train can carry the same load as more than 100 large trucks. Trains use less fuel per ton. They reduce highway traffic. They lower carbon emissions. But Australia's existing coastal rail line between Melbourne and Brisbane had serious problems. First, it is indirect. It bends around the coastline rather than taking the shortest path. Second, freight trains must share track space with passenger trains in Sydney. Passenger services have priority. That slows freight. Third, the route has sharp curves and steep slopes that limit speed. And most importantly, the old tunnels and bridges are too low to allow double-stacked containers. Double-stacked means containers placed 2 levels high on each wagon. This doubles capacity without doubling the number of trains. Without double stacking, rail cannot compete with road freight at the scale needed. So, planners proposed something new: a mostly inland route, designed for long freight trains. Built for double stacking from day one. It would not replace all coastal rail, but it would offer a faster and more efficient alternative. On paper, it made sense. But paper does not deal with real land, real weather, or real communities. Building 1,600 kilometers of railway across 3 states is not like building a single highway. The Inland Rail project is a mix of brand new tracks and upgrades to older lines that have existed for decades. And those older lines were never designed for modern freight traffic. To allow double-stacked trains, clearances must be increased. That means raising bridges, lowering tracks under bridges, rebuilding some crossings entirely, adjusting signals and electrical systems. These upgrades sound minor, but they are not. In March 2026, in the town of Broadford in Victoria, crews carried out a major operation. They had only 40 hours to demolish and rebuild the Short Street Bridge. The old bridge was too low for double-stacked trains. During the shutdown, passenger services were paused. Teams worked around the clock. If they failed to finish on time, the network would face widespread delays. This kind of high-pressure upgrade has to happen again and again across hundreds of locations. Each site presents its own challenges. Each carries financial risk. Each demands precision. And every unexpected issue adds time and cost. As construction moved north into New South Wales and Queensland, engineers faced a different enemy: the land itself. Some of the most difficult sections of inland rail cross floodplains. In early 2026, the government approved part of the project through the Guider Valley floodplain. On the map, it looks simple, just 12 kilometers of track. But floodplains are unpredictable. When heavy rain falls, water spreads across flat land. Soil becomes unstable. Ground movement can shift foundations. For railways, this is dangerous. Even small changes in ground level can cause track misalignment. To deal with this, engineers are building high, reinforced embankments. These are strong earth structures that raise the track above flood level. Deep foundations are installed to stabilize soft soil. Drainage systems are carefully designed so water flows around the railway instead of pooling under it. Engineers also plan to remove old bottlenecks, such as the Kimura hairpin. This sharp curve forces long trains to slow down. A straighter route improves efficiency, but it often requires building entirely new alignments across farmland. That creates tension. Farmers worry about land access. Communities worry about noise. Environmental groups worry about habitat disruption. Every megaproject faces this reality. Lines on a map become lines across someone's property. And every new alignment must balance national benefit with local impact. But even the cleverest engineering can't hide a growing problem in the spreadsheet. While engineers solved ground problems, another challenge was growing quietly: cost. The original estimate for inland rail was around $10 billion. But early cost estimates often rely on limited data. Once detailed designs begin, hidden problems appear. Unknown soil conditions, bridge replacements, land acquisition, inflation in material prices. By 2024, the projected cost had climbed to around $31 billion. An independent review examined what went wrong. It found that early planning had underestimated risk. Some assumptions were too hopeful. Experts called this optimism bias. Basically, that's a fancy way of saying humans tend to believe things will be easier and cheaper than they actually are. The structure used to manage the project was not fully prepared for its scale. This pattern is not unique. Around the world, large infrastructure projects often begin with lower cost estimates. As reality becomes clearer, budgets rise. For inland rail, the rising figure led to public debate. Was the investment still worth it? Would freight demand grow enough to justify the spending? These questions remain active today. In response to the rising cost and criticism, the government adjusted its strategy. Instead of pushing every section forward at once, the focus shifted to key priority areas. One major milestone came in February 2026. The 170-kilometer section between Stock and Bengal and Parks was completed and upgraded to handle double-stacked trains. 9 sites were improved to meet new clearance requirements. This section now forms a working backbone in the southern corridor. It proved that parts of inland rail can operate as intended, but major engineering challenges still lie ahead. One example is the Bethungra Spiral in New South Wales. Built in the 1940s, this spiral allows trains to climb a steep slope by looping over themselves. It is an impressive piece of historic engineering. But for 2-kilometer-long freight trains, it creates delays. Modern freight prefers flatter routes. So engineers plan to build a new alignment that bypasses the spiral entirely. This will improve travel time, but it also means new earthworks, new land acquisition, new cost pressures. The pattern continues. Every efficiency gain comes with a financial price. Today, inland rail is partly built and partly redesigned. Some sections operate. Others remain under review or planning. If completed as intended, the railway could change how freight moves across eastern Australia. It could remove thousands of trucks from highways each year. It could reduce congestion and lower emissions. It could support regional towns by improving access to ports and markets. But questions still hang over the project. Will future construction stay within budget? Will freight demand match long-term forecasts? Will the economic return justify the spending? Mega projects are never just technical challenges. They are tests of planning discipline, tests of political will, tests of public trust. Inland rail began as a bold national vision, a railway designed to reshape freight across a continent. Today, it stands as both a symbol of ambition and a lesson in complexity. Steel continues to stretch north, section by section. The trains may eventually run faster and longer than ever before. But until the final connection between Melbourne and Brisbane is complete, one question remains. Will inland rail be remembered as Australia's great transport breakthrough, or as one of its most expensive gambles? Only time and careful construction will decide. If you want to explore more mega projects shaping our world, consider subscribing.